This is lecture 3, part 4. In this lecture, I will discuss how to determine the thickness of a thin transparent film using biprism experiment. The biprism experiment can be used to measure the thickness of a given thin sheet of transparent material. If a thin transparent sheet is introduced in the path of one of the interfering beam, then the fringe system gets displaced towards the beam in whose path the sheet is introduced. By measuring the amount of displacement, the thickness of the sheet can be determined. Consider S1 and S2 are the virtual coherent monochromatic source. The point O is equidistant from S1 and S2, where we obtain the central bright fringe. Therefore, the optical path S1O will be equal to S2O. Let a transparent sheet Z of thickness T and refractive index mu be introduced in the path of one of the beam. After placing the sheet, the path S1O is not equal to S2O, and the central bright fringe shift from O to P. The light wave from S1 to P travel partly in air and partly in the sheet G. The distance traveled in air is S1P minus T, and the distance traveled in the sheet G is mu T. Since the optical path equal to geometrical path times refractive index of the medium, the distance traveled by the light wave to reach P from S1 is S1P minus T plus mu T. The distance traveled by the light wave to reach P from S2 is S2P. The path difference between S2P and S1P will give you equation number 1. According to the condition of constructive interference, for the nth bright fringe, the path difference in equation 1 will be equal to n lambda. If you rearrange this equation, you will get equation number 2. We know from the Young double-slit experiment PS2 minus PS1 equal to x n d divided L. If you substitute PS2 minus PS1 equal to x n d divided L in equation 2, you will get equation number 3. If you rearrange equation 3, then you will get equation number 4. In equation 4, the distance x nt represent nth bright fringe with the film Z. In the absence of the film, when t equal to 0, the distance of the nth fringe from the point O is given by xn0 equal to ln lambda divided d. So this is equation number 5. We have already derived equation 5 in Young double slit experiment. See the lecture 2. Therefore, the displacement of the nth bright fringe is obtained by subtracting equation 5 from equation 4. If you subtract equation 5 from equation 4, you will get equation 6, which gives the amount of displacement of the fringe. If you rearrange equation 6, then you can write equation 7. Measure the distance L between the source and the screen and the distance D between the two source S1 and S2 and the amount of displacement of the fringe x0 using biprism experiment, and calculate the thickness of the film of non-refractive index using equation 7.